The exponential function for grade ES. Part 2. In this part كنا نحكي عن derivative, limits, and the curve of the exponential function defined by f of x equal exponential x. Derivative of the exponential function. If f of x equal exponential x, then f prime of x equal exponential x. The derivative of exponential x does not change. Example. Calculate the derivative of the function defined by f of x equal x squared minus 3x plus ex. The derivative of this function is 2x minus 3 plus ex, where 2x is the derivative of x squared and minus 3 is the derivative of minus 3x plus ex, where ex is the derivative of ex. If f of x equal x minus 3 into ex, this function at the form of u dot v, then f prime of x at the form of u prime v plus u v prime, where u equal x minus 3 and v equal exponential x. Then f prime of x equal x minus 3 prime into ex plus x minus 3 into ex prime. And the derivative of x minus 3 is equal to 1. The derivative of exponential x is exponential x. Then f prime of x equal 1 ex plus x minus 3 into ex. Take exponential x common factor, we get f prime of x equal x minus 2 into ex. If f of x equal x squared minus 4x into ex, this function at the form of u dot v, then f prime of x at the form of u prime v plus u v prime, where u equal x squared minus 4x and v equal exponential x. Then f prime of x equal to x minus 4, where to x minus 4 is the derivative of x squared minus 4x plus u x squared minus 4x into ex, where ex is the derivative of ex. Take ex common factor, we get f prime of x equal x squared minus 2x minus 4 into ex. If f of x equal ex over 2x plus 1, this function at the form of u over v, where u equal exponential x and v equal to x plus 1, then f prime of x at the form of u prime v minus v prime u over v squared, where u prime is ex, the derivative of ex, and v prime equal to the derivative of 2x plus 1. We get f prime of x equal ex into 2x plus 1 minus 2ex over 2x plus 1 squared. Take ex common factor from the numerator, we get f prime of x equal exponential x into 2x minus 1 over 2x plus 1 squared. If f of x at the form of 2ex minus 3 over 3ex plus 1, f prime of x equal u prime, the derivative of u 2ex minus 3, 2ex into v 3x plus 1 minus v prime, the derivative of 3x plus 1, 3ex into u 2x minus 3 over v squared. Expand and reduce the numerator of the f prime of x, we get f prime of x equal 11ex over 3ex plus 1 square. if f of x at the form of exponential u, then f prime of x equal u prime eu, where u prime is the derivative of u. Example, calculate the following of the function defined, the derivative of the function defined by f of x equal e3x, this function at the form of exponential u, where u equal 3x and u prime equal 3. Then f prime of x equal u prime eu 3e3x. If f of x equal exponential x squared minus 5, this function at the form of exponential u, where u equal x squared minus 5 and u prime equal 2x. Then f prime of x at the form of u prime eu, f prime of x equal to x ex squared minus 5. If f of x equal x cubed minus 4 into e to x, this function at the form of u dot v, where u equal x cubed minus 4 and v equal e to x. Then v prime equal 2e to x, since e to x at the form of exponential u, then v prime equal u prime eu, where u equal to x and u prime equal 2. Then f prime of x equal the derivative of 3x, the derivative of x cubed minus 4, 3x squared into v e to x plus x cubed minus 4 into v prime 2e to x. Take e to x common factor, we get that f prime of x equal 2x cubed plus 3x squared minus 8 into e to x. If f of x equal e to x over ex minus 1, this function at the form of u over v, where u equal e to x, then u prime equal 2e to x and v equal ex minus 1, then v prime equal ex. Therefore f prime of x equal u prime into v minus v prime into u over v squared. Expand and reduce the numerator of f prime of x, we get f prime of x equal e3x minus 2e to x over ex minus 1 squared. But e3x فينا نكتبها at the form of exponential to x plus x, since to x plus x is 3x, and exponential to x plus x equal exponential to x times exponential x, since exponential a plus b equal exponential a plus times exponential b. Then e3x equal e to x into ex. Take e to x common factor between e3x and 2e to x. We get f prime of x equal e to x into ex minus 2 over ex minus 1 squared. Homework: calculate the derivative of the function defined by limits. The limits where x tends to minus infinity, the exponential x is equal to 0, and the limit where x tends to plus infinity, the exponential x equal to plus infinity. Limit where x tends to minus infinity, the x exponential x equal 0 minus. خلينا نشوف ليه. If we replace x by this value minus infinity, we get minus infinity times exponential minus infinity times 0, since exponential minus infinity is equal to 0, This is an undetermined form. حنصير نتبع آليات ولما يكون عندي limit لبولينوميال مضروب بإكسبرنشن بيعطيني undetermined form. أول شي بنستخدم الرول للإكسبرنشن وبنعمل له change of place from numerator to the denominator. إذن يصير limit لما ال x tends to minus infinity ل x over exponential minus x. وقت ما بنعمل change of place للإكسبرنشن بنعمل change of sign للباور. شوف كانت x صارت minus x. بما انه صار عندنا limit للفراكشن is undetermined form صار فينا نطبق orbital rule. Then by orbital rule limit لما ال x tends to minus infinity ل x over exponential minus x equal limit لما ال x tends to minus infinity ل 1 over minus exponential minus x. orbital rule بتقلنا بنعمل derivative للنيميريتر لحال ودerivative للنيميريتر للدينومينيتر لحال. derivative لل x equal 1 derivative ل exponential minus x equal minus exponential minus x. هلا بنعوض ال x بقيمتها minus infinity we get 1 over minus exponential minus infinity 1 over minus exponential plus infinity and exponential plus infinity equal plus infinity. Then limit لما ال x tends to minus infinity ل 1 over minus exponential minus x equal 1 over minus infinity equal 0 minus. Limit where x tends to plus infinity ل exponential x over x. If we replace x by this value x plus infinity, we get exponential plus infinity over plus infinity and determinate form. Then we apply orbital rules, we get limit where x tends to plus infinity exponential x over 1 equal exponential plus infinity over 1 equal plus infinity. Limit where x tends to 0 exponential x minus 1 over x is equal to 1. If we replace x by this value 0, we get exponential 0 minus 1 over 0 and exponential 0 is equal to 1. Then 0 over 0 and determinant form. كمان عندنا fraction نستفيد من orbital rules. تصير limit لما x tends to 0 the derivative of numerator is exponential x and the derivative of numerator is 1. Replace x by this value 0, we get exponential 0 equal 1. Then limit where x tends to 0 the exponential x minus 1 over x is equal to 1. هون ثلاثة فينا نطبقهم بالامتحان بشكل مباشر directly بدون ما نرجع نبرهن rules. exponential minus infinity equal 0 and exponential plus infinity equal plus infinity. Examples. Limit where x tends to minus infinity exponential x plus x minus 2. Replace x by this value minus infinity. We get exponential minus infinity minus 2 and exponential minus infinity is equal to 0. Then this limit is equal to 0 minus infinity minus 2 equal minus infinity. Limit x tends to plus infinity the exponential x plus x minus 2. Replace x by this value, we get exponential plus infinity minus 2 and exponential plus infinity is equal to plus infinity. Then this limit is equal to plus infinity. Limit where x tends to minus infinity of exponential x squared minus 2. Replace x by this value minus infinity, we get exponential minus infinity squared and minus infinity squared is a plus infinity. We get exponential plus infinity minus 2 and exponential plus infinity is equal to plus infinity. Then this limit is equal to plus infinity. Limit where x tends to minus infinity the exponential to x plus exponential x plus 3. Replace x by this value minus infinity. We get exponential 2 into minus infinity, and 2 minus infinity is equal minus infinity. Then we get exponential minus infinity plus exponential minus infinity plus 3. And exponential minus infinity is equal to 0. Then this limit is equal to 3. Limit where x tends to plus infinity x exponential x. Replace x plus infinity in this value. We get plus infinity into exponential plus infinity, and exponential plus infinity is a plus infinity. Then this limit is equal to plus infinity into plus infinity equal plus infinity. Limit where x tends to plus infinity exponential minus x plus x minus 2. If we replace x in this value, we get exponential minus infinity. Minus plus infinity is a minus infinity. Exponential minus infinity is equal to 0, and plus infinity minus 2, we get plus infinity. Limit where x tends to plus infinity x exponential minus x. If we replace x by plus infinity, we get plus infinity into e to the power minus infinity is a 0. This is a undetermined form. أكيد بس يطلع عنا undetermined form نحن عم نجيب limit لبولينوميال مضروب بإكسبوننشال مثل ما اتفقنا. نعمل change of place للإكسبوننشال وننبه من النيميريتر للدينومينيتر، وبس نعمل change of place للإكسبوننشال نعمل change of sign للباور of the exponential. We get limit where x tends to plus infinity لx over exponential x by orbital rules. جيب derivative للنيميريتر derivative للدينومينيتر. We get limit where x tends to plus infinity ل 1 over exponential x equal 1 over plus infinity equals 0. Limit where x tends to plus infinity ل x squared plus 2x minus 3 into exponential x. If we replace x in this value plus infinity, we get this limit is equal to plus infinity into exponential plus infinity. Then we get plus infinity times plus infinity is a plus infinity. Limit where x tends to plus infinity to x plus 1 over x minus 3 into exponential x. نجيب limit led to x plus 1 over x minus 3 times limit exponential x. And this limit نعرفه من يا إما by orbital rules لأنه fraction، أو يا إما بناخد the height degree over the height degree ونعمل simplify للx. We get this limit is equal to limit where x tends to plus infinity exponential x is equal to plus infinity. 2 times plus infinity is equal to plus infinity. Limit where x tends to minus infinity x plus 2 into exponential x. Replace x in this value minus infinity, we get minus infinity into exponential minus infinity into 0 and determinant form. فينا نعمل change of place للإكسبوننشال من النيميريتر للدينومينيتر ونطبق orbital rules مثل ما شفنا قبل، فنحصل على limit 0. أو هون فينا نعمل expand to limit where x tends to minus infinity ل x exponential x plus 2 exponential x, and this limit نعرفه من الرولز 0 اللي فينا نستخدمه directly, and 2e minus infinity is equal to 0. We get this limit is equal to 0. Limit where x tends to plus infinity x squared plus 2x minus 3 into exponential minus x. If we replace x in this value plus infinity, we get plus infinity into exponential minus infinity, and exponential minus infinity is equal to 0. Then we get plus infinity into 0 and determinant form. كرمال هيك عنا بنعمل change of place للexponential. عندنا polynomial into exponential. نعمل change of place للexponential من numerator from the denominator. We get limit where x tends to plus infinity ل x squared plus 2x minus 3 over exponential للx. عملنا change of sign للpower بس عملنا change of place للexponential. And we apply orbital rules. We get limit where x tends to plus infinity that 2x plus 2 where 2x plus 2 is the derivative of x squared plus 2x minus 3 over exponential x where exponential x is the derivative of exponential x. If we replace x in this value plus infinity, we obtain plus infinity over plus infinity in determinant form. Then we apply orbital rules second time. We get limit where x tends to plus infinity let 2 over exponential x where 2 is the derivative of 2x plus 2 and ex is the derivative of ex. Replace x in this value plus infinity, we get 2 over plus infinity is equal to 0. Then by orbital rules 2 times, limit where x tends to plus infinity x squared plus 2x minus 3 into exponential minus x is equal to 0. Limit where x tends to plus infinity ل 2 exponential 3x minus 3 over 3 exponential x plus 1. If we replace x in this value, we get plus infinity over plus infinity. And this is a undetermined form. Then we apply orbital rules. The derivative of 2ex minus 3 is equal 6e 3x. And the derivative of 3ex plus 1 is 3ex. e3x over ex is equal ea over eb exponential a minus b. Then e3x over exponential x is equal exponential 3x minus x exponential to x, and 6 over 3 is equal to, replace x in this value plus infinity, we get 2 exponential plus infinity is equal plus infinity. Limit where x tends to 0 exponential to x minus 1 over x. If we replace x in this value 0, we obtain 0 over 0 undetermined form. Then we apply orbital rules. Then this function at the form of fraction. Then we apply orbital rules. Then this limit equal 2 exponential to x where 2 exponential to x is the derivative of exponential to x over 1 where 1 is the derivative of x. Replace x 0 in this value. We get 2 exponential 0 over 1 and exponential 0 is equal to 1. Then this limit is equal to limit where x tends to plus infinity ل x exponential x minus exponential x. If we replace x in this value, we get plus infinity minus plus infinity is the undetermined form. وبس نحصل على undetermined form على شكل plus infinity minus infinity بنحاول ناخد common factor. وبس كنا عم نشتغل بالاكسبوننشال ناخد الاكسبوننشال common factor. فإذا ناخد ex common factor. We get limit where x tends to plus infinity لل ex into x minus 1 على طول بس يكون عندنا plus infinity minus infinity and determinant form. ناخد الدومينانت common factor والexponential is the dominant على البولينوميال ويقوى من البولينوميال، فكذلك بناخد الاكسبوننشال common factor. Replace x in this value plus infinity, we get plus infinity into plus infinity equal plus infinity. Homework. The curve of the exponential function in the orthonormal system. The first remark: the exponential function is a function defined and continuous for every x belongs to R. Limit where x tends to minus infinity the exponential x equals 0, then y equals 0 is a horizontal asymptote and y equals 0 is x-axis, the axis of abscissa. Then x prime or x is an asymptote to the curve C of the function f. Limit where x tends to plus infinity the exponential x equal exponential plus infinity equal plus infinity. فنقدر نرسم الكيرف لازم نعمل table of variation. فإذا f prime of x لازم نجيبها f prime of x equal exponential x, and by definition of the exponential x is positive for every x belongs to R. Then the table of variation x, the domain of definition minus infinity to plus infinity, f prime of x is a positive and f of x is increasing from 0. ما في عنا خطأ مطبعي صغير. f of x is continuous from 0 to the plus infinity. أكيد لو نرسم الرسم بناخد 2 particular point أو 3 particular point where x equals 0 exponential 0 equal 1, where x equal 1 exponential 1 equal e and e equal 2.7, where x equal 2 exponential 2 equal 7 point. Then we get the 3 point A, B, C or a point on the curve of the exponential. Now I replace the A will be 1e, C 2e power 2. ومناش ننسى انه عنا x axis is the asymptote of the curve C. فإذا curve is increasing where from 0 where x tends to minus infinity, where x tends to minus infinity the coordinate of the curve is 0, and increasing passing through the point A 0 1 and to the point B 1e and to the point C 2e square and complete to the plus infinity. أتمنى التوفيق والنجاح للجميع.